right, everybody. Welcome to our August Akka.net community stand-up. My name's Aaron Standard, and I'm joined here by Gregorius Sodharmo on our team. Gregorius, how
Hello.
are you doing?
Oh, pretty good. Thank you very much.
Yeah, good, good. Let me go ahead and grab our agenda real quick. I'm starting a little bit behind today. My apologies for that. Okay, there we go. I think I've got it up in front of me. All right, let me share my screen. And we will do this one. Apparently, I'm using dark mode for everything these days. But yeah, here we are. Okay. So we've got a number of different things to go ahead and cover today. I guess the first place we should really start is talking a bit about some of our prior Akka.net releases that we've done since, I guess, really since our last community stand-up, which was in July. We didn't have a lot going on. No, sorry, our last community stand-up was in June. We didn't really have a lot going on in July. I was traveling throughout most of June for NDC Oslo at the very beginning. And then I had some trainings and other business trips that I was doing. And then even during the first week of July, I was abroad there. So we didn't ship a whole lot of open source stuff, but that is not the story for the month of August. So I guess we'll begin with Akka.net 1.59. We made some parts of Akka.remote public, and we improved a number of memory optimizations and a couple of logging calls. And one of the other things that we worked on is Simon Kropp. So big hats off to him, a major .NET open source contributor, helped us add the polyfill project to Akka.net, which has allowed us to start taking advantage various tools like record types, for instance, in certain parts of Akka.net. So we've actually had that in place for a little while now. I think before we did Akka Delivery, which came out in May, I think we had already added polyfill to some of it. But we made a lot more changes, doing things like taking advantage of some new C# syntax and operators. So that was kind of the gist of 1.59. And we've actually done another 3 releases since then. Let's see, 1.510. This was a stupid change we had to do to fix the Akka.Persistence compliance kit. We did that. Akka.511. We basically made some changes to .NET, namely just the way the TLS sort of configuration works. And this is so we could easily support this in Akka.Hosting, which I think you're talking about next on the agenda, Gregorius. So we did that. And then we also made and distributed PubSub, the account subscriber query. We made that public. That was very useful for solving a variety of different eventual consistency problems with the distributed PubSub. If you need to know if there's any subscribers on any node inside the network currently subscribed to this topic, as far as your publishing node knows, now you can just go ahead and issue this query to the mediator, get a response back. And if the integer value you get back is greater than 0, now you know that you've got someone on the other end of the line listening to your messages. And then we did just last week Akka.net 1.512, which fixed apparently a pretty long-standing bug that's gone unnoticed with Akka.Persistence query because it didn't really have any negative side effects. Do you want to talk about these 2 Akka.Persistence query changes that we made in 1.512, Gregorius?
Yeah. The first one had to do with how concurrent dictionary was working. If you have 2 journals, the read journals being instantiated at the same time, both of them actually get instantiated before it is added to the concurrent dictionary. Of course, this is a problem when the code inside the journal strictly requires that it can only be like instantiated once, like if it has like a very strict actor name in it. So we need to change that and fix it basically.
Yeah, so that was one. And then we also exposed the tags that belong to each event on the event envelope. That's the kind of the return value you get back when you are querying now. So that should make it a lot easier. Tags are were always this sort of somewhat extraneous thing, but now we've made it sort of fully integrated into the data that you get back from Akka.Persistence query. So that should be a lot more useful going forward too.
One note though, not all persistence plugins will support it. So
That's true.
make sure that you pay attention to the persistence plugin that you use.
Yeah, we might need to go and make some updates to some of them in order to add support for that if that's a desired thing. But at least now the capability's there if we want to
Mhm.
on it, whereas it was not before. So that's what we've gotten done on the Akka.net core front. Next, we've got Akka.Hosting. And let's see, you fixed one pretty big bug with the Akka.Hosting test kit. This one I've personally run into a number of times. And you
Yes.
also added SSL support. Why don't you talk about that real quick?
The missing actor context inside the hosting test kit is a bit of a weird bug that was caused by thread static. The problem is that the host does not that actually runs the test is not in the same thread as the actor system inside the host. So that causes the actor context not being synchronized between the two of them. So we
That
fixed that.
Yeah, that was a nasty one.
hmm
Uh,
And
then
we
yeah, go ahead.
we actually added SSL settings to remote options now, so people can actually start using SSLs in hosting.
Yeah, so that was something I noticed when I was doing one of my on-site trainings for an Akka.net customer back in July. Was this company's very security focused, and they've been kicking the tires on Akka.net for many years. And Akka.Hosting was something new that they hadn't really interacted with much. And they had seen some of our videos on it, but hadn't actually used it. And they said, "How do you configure SSL with Akka.Hosting?" And I said, "That's a good question." And I'm doing this live on screen in front of 10 people during my training, and I realized there's like nothing for configuring it. And I'm like, "Oh, yeah, I'll file a GitHub issue. We should fix that." So, promise is made, promise is kept. As far as those, if any of those customers are watching. Um, let's see. Next, we have Akka.HealthCheck. The big change we made here was relaxing the probe requirements. If I go back to the discussion issue, I'll go ahead and kind of, even though you're the one who fixed it, Gregorius, I reported it, so I guess I'll I'll comment on it real quick. Um, so there was kind of an interesting conundrum here that got reported with the Akka.cluster health checks, which is okay. The checks that we had before for liveness and readiness for Akka.cluster. So if you're not familiar with Kubernetes, these are two different discrete types of health checks. A liveness check, if a process doesn't pass that, it's going to get pretty much immediately killed and recreated. It means that there's something has gone critically wrong. A good example from a Kubernetes standpoint, if the process has exited without Kubernetes being told that it was going to do that, Kubernetes will automatically restart you. Likewise, if let's say you depend on connectivity to SQL Server and you lose connectivity to it, the Akka.Persistence liveness probe will flag that and it'll force that process to get restarted. That's what liveness checks are all about. Can this process actually continue in the state that it's currently in? The readiness health check is a little bit more subtle than that. It's more like a load balancer health check where the process might be alive and it might be nothing's gone wrong, but it might not be fully initialized yet, not quite ready to serve customers. That's part of the issue there. Well, a couple things that we discovered in the course of working with customers that are actually using these solutions was two things. First, the liveness probe became unhealthy when the node just started and has not joined a cluster. Okay, so what problem could that cause? Well, if you're using this in combination with the tool like Akka Management, and it takes a minute to go ahead and form a cluster, Kubernetes might notice a whole bunch of pods that have not passed their liveness checks, and it's going to give you a grace period, and you can actually configure that to be longer or shorter. But you run the risk of your cluster basically being killed as it's trying to start. So that's not great. So we changed that so the liveness probe only fails when the node's leaving the cluster, which is fine. If you killed the process at that point anyway, it wouldn't cause any problems. Um, Apologies if you all can hear the cargo train passing by our office here. We are about 200 yards from a railroad track, and that's what that is there. Okay, the readiness check for Akka.cluster. This will report unhealthy when the actor system has just started and not joined a cluster, and historically would report when all the nodes in the cluster were unreachable. Well, again, the same problem. If we're reporting that this node isn't healthy as it's trying to join the cluster, uh, Kubernetes might do things like not make its domain name available. That might be an issue that comes up. So there's all sorts of different potential knock-on effects from marking these pods as unhealthy at this stage. So we relaxed all those constraints and made it so it's much more black and white. Basically, when the readiness check will fail when all the nodes in the cluster are unreachable. That usually means that this specific pod is having trouble contacting everybody else, and it's going to need to get restarted. If a readiness check goes on long enough without passing, it'll be the exact same condition as when a liveness check fails. So this is much more germane and honestly user friendly than what it was before. And we kind of fixed this as a result of feedback from some of our Kubernetes users. So that was that. And now we're going to.
Also,
Oh, go ahead, Gregorius. I'm sorry.
also there's a nasty circular problem with readiness check. Uh, Akka needed to join the cluster before it declares itself ready. But sometimes Kubernetes would not start another pod until the first pod is ready.
Yep. And if you're using Akka management in particular, that's a problem. Where if you're launching a cluster for the first time, and let's say you're spinning up, I don't know, 4 different Kubernetes services, 3 pods each, and you have to have a minimum quorum of, let's say, 5 pods. Well, you'll get 4 pods, 1 from each service, but not that 5th one until the other ones pass their checks. So yeah, I think the default quorum number we usually recommend is 3. That's like the minimum numbers count. But so that wouldn't be an issue in that scenario, but still, we needed to go ahead and do a little bit of cleanup around Akka.HealthCheck, and we did. So that's all said and done. Now the big kahuna that we're really here to talk about today is Akka.Persistence.Sql, which just came out of beta yesterday, in fact. Gregorius, you have been working on this as like your primary project for a good stretch of this calendar year so far. Do you want to go ahead and kind of share? So let's do this. Why don't you share in broad strokes with the Akka.net community? What's the purpose of this plugin and why did we build it? And, also we got to thank Andrew, who's, let's see, let me grab his username here. T001, TO11MTM, who's the original creator of this plugin. Gregorius picked up his work where Andrew left off and brought it through to completion and basically kind of helped it basically become a suitable drop-in replacement for Akka.Persistence.Sql, but the original architecture design was Andrew's work. So we want to give credit where it's due there. So why don't you just go ahead and talk a little bit about the motivation behind this plugin and why we spent so much time developing it, Gregorius?
The initial push to do it is to basically deprecate the other plugins that are based on Akka.Persistence.Sql comment. The problem we have there is that there's so many flavors of it out there with different codes inside of them. Maintaining them becomes, a real chore because a single change has to be propagated to like 5 other plugins, and we have to make sure that everything works and all of that. With this, we only have one source code, one source of truth that we can easily maintain, and it supports basically almost all type of RTMS under the sky.
Yeah. So the problems that Gregorius mentioned, this is like a form of technical debt that's taken us half a decade to pay off, which is basically that the original. So the way the Akka.net project kind of got started, there were a lot more contributors who had a lot more, let's say, sort of day-to-day sort of work and responsibility in the project. These days, it's basically kind of a benevolent dictatorship. Sort of how our project operates. It was much more kind of a council of contributors in the earlier days. And I was not very involved in any of the Akka.Persistence or Akka streams or cluster sharding, really. I was kind of very, very laser focused on Akka.Cluster itself, Akka Remote, and some of the other core infrastructure in Akka itself, such as like the mailbox system and the dispatching and all that. That's kind of where my focus was. This is like 2015, 16, 17 that we're looking. I think Akka.Cluster itself finally got out of beta, I think in 2017. Maybe no, it was 2016. Akka.net 1.1 is when we got that out. So that's kind of where my focus was during the early years of the project. Meanwhile, the work that was happening on Akka.Persistence was basically decided that each plugin should just do things as the author sees fit. There wasn't really going to be sort of a singular serialization format or a standard schema or other sort of standard ways of doing things beyond what the TCK could and would enforce. So that's kind of how all these different packages, there's probably a dozen different Akka.Persistence packages all developed originally. Now, that started to become a problem once we ran into issues. Like an example I remember very viscerally was MongoDB, for instance, serialized all of its data using the native BSON format, which ended up meaning that things like serializing actor references actually couldn't work correctly under a lot of circumstances, which meant that you couldn't use MongoDB as the backing store for Akka.Cluster sharding, for instance. And that's just one example of a problem. There's been dozens of them over the years. I remember, I think 2016 or 17, I think it was maybe 2017 and 18. I wrote up a thing about standardizing the Akka.Persistence schema across all these plugins because I had spent probably 250 hours that year dealing with just problems that related from all these authors all doing their own thing everywhere else, where every time I wanted to try to debug an Akka.Persistence plugin, I had to throw all my assumptions out around how it was supposed to work because everyone had done their own thing. So a good example with the SQL world was Postgres supports 3 different storage modes for all of the data that can be stored inside of there. And we still retroactively support some of that in Akka.Persistence.Sql, but going forward, we have kind of a standard way of performing serialization. So that way it works consistently well, supports all the other features that we need to support, like actor ref serialization, and is basically a little bit more straightforward. So that was one big motivation here, is to kind of standardize and professionalize all the Akka.Persistence plugins. The other big motivating factors behind Akka.Persistence.Sql come down to performance. And you know what? On a separate screen here, I'm going to dig up one of my slides from our upgrade video that we just did. Let me go ahead and grab that. This was our that screen I just had there had all of the test coverage experiments you were doing today, Gregorius. We're experimenting to see if unit test coverage is a useful metric. So far, we are undecided. We might end up deciding that it's useful. We'll see. But let me pull up our. If I go to Dropbox, I gotta go to my marketing folder and grab my PowerPoint. Let's see. Too many different directories here, man. Guess I should have been better prepared today, huh?
Just a tiny bit.
Well, we're going with open source production values here, all right. I'll just pull this up. All right. So let's go ahead and take a look at the reasons why you might want to consider upgrading to Akka.Persistence.Sql. And of course, I'm showing the wrong window. Silly me. Let me try that one more time. We'll go ahead and do just my entire screen. There we go. Okay. So why would you want to consider upgrading to Akka.Persistence.Sql? These are the performance numbers taken between Akka.Persistence.Sql server, including the batching mode, which is considerably faster in some cases than the normal mode is, although it looks to me like it's not all that much faster. Persistall async is actually faster without batching, which blows my mind, but whatever. And then this is Akka.Persistence.Sql right here. As you can see here, let me grab my pen. On the right side, we're averaging, actually, that's the recovery side. So let's go ahead and redo that. Drawing on screen with PowerPoint's always been one of those kind of hit or miss type deals. All right, let me grab this real fast. But basically, we are looking at, in most cases, a 70% or 63% bottom line improvement over Akka.Persistence.Sql server as far as writes are concerned. And by the way, these numbers will hold up for Postgres, MySQL, and Ishmael, if you're watching, I hope it'll hold up for Oracle. We're not going to find out on our end. It's going to be up to you. But I think based off some of the numbers that Ishmael posted a couple years ago, when Andrew was first starting his work on this, looks like the Oracle writes are faster. Under the covers, Akka.Persistence.Sql uses link2db, which is not to be confused with link2SQL. Link2db is kind of a abstraction layer over ADO.NET that it very much is in the spirit of link2SQL, but it's never been a Microsoft technology. It's always been third party. So we use that under the covers, and we do a lot of work to make write performance much faster. As you can see here with persist async, we're like 3,000% faster than we were before. So if you were ever constrained by SQL servers, by Akka.Persistence.Sql servers write throughput, this will be a significantly faster improvement for you. We're a little bit slower on recoveries. That's kind of one of the trade-offs here with Akka.Persistence.Sql. But one thing that's worth pointing out is you get rate limited by Akka.Persistence when you start having more than 50 concurrent recoveries anyway. So this number levels off once you start having a much larger number of actors recovering all at once. But at very small numbers of recoveries, it is a tad slower than what we were doing before. And that makes sense. Link2DB's got its sort of little abstraction layer in front of ADO.NET. Whereas we were using basically just raw ADO.NET stuff before without any type of ORM at all in there, other than our own manual mapping code. The other really big motivating factor for Akka.Persistence query is one of the goals we had for Akka.NET 1.5 was to try to support CQRS, Command Query Responsibility Segregation, a lot better than we did before. In our April community stand-up, which we'll link to here, we actually gave a presentation about Akka.Persistence.Sql and how we are intending to go ahead and achieve that. Well, now we've got some numbers to share with all of you on that. So correct me if I'm wrong, Gregorius, but these tables had 1 million records inserted into them with
That is correct.
10,000 tagged entries at the maximum that we were trying to retrieve, 10,000 out of 1 million, right?
Mm-hmm. Yep.
Okay. So let's go ahead and take a look at the numbers real quick. So we're starting with 1 million items for each of these. So if I grab my pen, you'll notice that all these queries take roughly 1.7 seconds to execute using Akka.Persistence.Sql server using the CSV, comma separated value. The way we stored tags in these older persistence plugins was basically every row, which represented one event in the event journal, would have a text field that had a comma separated values for tags. This meant that when you wanted to do a tag based query, I'll talk about what tags are in just a second. But when you wanted to do a tag based query, it was a full table scan plus having to parse those comma separated values out of each one of the items in the table. We have some customers that have event journals that are like greater than 1 billion events in length. So imagine how poorly this query would perform on a data set that is over 1,000 times larger than this. Not great. It's basically a I'll put it. It'd be zero O of n would be the speed that each of these queries would take, where n is the total number of items in the table. Whereas with the tag table, which is a new covered sort of index table that we built for tags, now we're able to go ahead and reduce the query times to like milliseconds. Now, the reason why this item down here, why these two took longer, is when we paginate queries in Akka.Persistence, we do them in batches of 100. So this change in throughput right here has more to do with the way Akka.Persistence query is doing pagination inside the actors than it does with the actual overhead of the way we're using SQL Server. That's sort of the reason why there's a difference in performance there. These two queries require 1 page. This one requires 10. This one requires 100, which is why you're starting to see that sort of linear increase in latency there. Still, we're an order of magnitude faster than we were before. So that's kind of another big motivating factor for us is trying to improve the performance of tags. Now, what a tag is in the context of Akka.Persistence query, a tag is a way of creating a secondary index on events. So imagine you're building like a stock trading application and all of your entities represent specific ticker symbols. So Microsoft, Apple, Google, Netflix, all that jazz. So if you wanted to go ahead and use Akka.Persistence query to gather data about all the different trades or proposed trades that have been made against an order book for a stock ticker symbol, that's pretty straightforward. You would just do a query by persistence ID operation, and you could just go ahead and tail all the events that belong to that persistence ID in the journal. That's pretty easy. Well, what if you wanted to get all of the matched trades? Let's say that like a match event. This means that a buy and a sell order matched on price, and there was enough available volume to cover the purchase order. Well, what you would basically need to do then is you'd add a tag. You'd add a match tag representing that on this order book for this ticker symbol, this was a match operation. Or you could have a bid operation when someone's trying to buy, or an ask operation when someone's trying to sell. And you can go ahead and basically scan in the event journal for all the events that have those different dimensions added to them. That's what tag queries are for, and they're another very useful tool for doing projections with Akka.Persistence query. We recognize that the way we were doing things with SQL Server was really not ideal and needed to be improved. Tag queries have worked historically pretty well. Platforms like Akka.Persistence.Azure supports them really well. MongoDB does, but all the relational database ones had this same issue where basically it was doing full table scans. Now, other reasons you might want to consider upgrading. We standardized the anti-corruption layer in Akka.Persistence for all these relational databases. This basically detects when multiple entities are trying to write to the same persistence ID at the same time, which is illegal and can result in data corruption. And we do that by basically looking at this writer UUID field. Each journal actor, the actual actor that runs Akka.Persistence, has a GUID it generates at runtime. If Akka.Persistence sees that multiple GUIDs are appearing at the same time, basically overlapped for the same entity, we know there's a corruption problem. And so we can detect that and basically kill the entity in both places when that occurs. So this is a very useful tool for trying to detect corruption. And this would usually occur either as a result of something like a split brain. More often than that, it's usually a programming error. It's typically why it shows up. It means the developer is misusing the persistence IDs, or they're using the wrong configuration setting or whatever. The other thing that we are going to do is we're eventually going to deprecate all the other Akka.Persistence SQL plugins. We're going to start work on Akka.NET 1.6 at the beginning of next year. Our next big project that we're working on beginning in Q4 of this year is we're working on redoing all of our tutorials, documentation, and examples, trying to modernize all of that, provide better learning materials for new users. And really, we're trying to reduce the total cost of adoption for people that want to either bring new developers onto their Akka.NET projects or people that just want to adopt Akka.NET for the first time. That's kind of our big project for the next quarter. This quarter, I'm actually going to write a blog post about what we're doing now. We're rewriting SDK bit. We'll talk a bit about that separately, since that's not really an Akka.NET issue. But that's kind of what we're working on for the rest of this year. Akka.NET 1.6, we're planning on starting work on that in Q1 of next year. And we're going to, once that sort of sprint to get Akka.NET 1.6 developed is complete, we will be deprecating all the older Akka.Persistence plugins. You probably will have about a year before you need to worry about that. But this is a good time to start taking a look at Akka.Persistence.Sql. If there's issues with it, if the upgrade paths that we've created don't properly support you, good time to start letting us know about all of that. We will be furiously working to try to make sure that this works for you. I should go ahead and mention, let me discard my ink here. There's two different upgrade modes. And by the way, we'll link to this video here as well. We produced on Monday a full-blown upgrade tutorial. And in fact, Gregorius, you linked to it in the README right here. We have a migration tutorial video. And we also have a written migration guide and a written migration tutorial, all of which cover all the bases for trying to actually execute this migration. So one thing I'll mention is there's two upgrade paths. There's compatibility mode. This basically means you can start using the Akka.Persistence.Sql engine without applying any schema upgrades to your code. So if you're worried about downtime, for instance, because you actually do need to do the schema upgrade, which is what we recommend. The schema upgrade adds the anti-corruption layer and it adds the tag table. That's basically the benefit of it. If you don't care, you've been using Akka.Persistence successfully for years without either of those, you can just stay in compatibility mode. This will just swap out the engine. It'll read and write the data the exact same way the old plugin did before, just significantly faster. You get all those performance improvements we showed earlier, minus the tag table stuff. So that's available to you as one upgrade path. You can do that to kind of validate that everything works. And then if you want to take advantage of the new features we added, there's some very simple SQL upgrade scripts that we've made available in the repo that'll help you move on to it. And we walk you through all the steps on how to do that in the YouTube video, which we're not going to live reenact all of that here, but that is available. So that's kind of worth taking advantage of. Gregorius, did I leave anything important out as far as Akka.Persistence.Sql goes?
No, that's pretty much it.
Okay, good. It does use LinkedIn under the covers. So the one thing you will need to do a little bit differently when you are installing the NuGet packages is, in addition to installing the Akka.Persistence.Sql NuGet package, you'll also need to install the appropriate NuGet package that contains the database drivers you need for your distribution. So that's going to be the SQL client package for SQL Server, and that might also include things like MPG SQL for Postgres. Yeah, that's just one little thing, and I think we document that somewhere in the README. You'll have to correct me if I'm wrong on that, Gregorius, but that's the kind of a requirement that LinkedIn has. We don't want to bundle all the possible drivers and ship them in here. You just get to go ahead and install the one that works best for you. So that's one additional kind of step that we didn't used to have before. But that's one of the benefits of standardization is basically that it'll work with any ADO.NET compatible driver. Let's see. Future plans, we kind of talked a bit about those. We're going to be working primarily on documentation and tutorials. For our September community stand-up, I think we are in the process of communicating with a couple of people about potentially speaking there to do our show and tell. But otherwise, you will hear from us in September. Thank you very much for your time and attention as always. We really appreciate you, and we appreciate your continued support on the Akka.NET project. And please give us any feedback you might have on any issues you might be running into. And don't forget to join the Akka.NET Discord. We'll see you in there as well. So thank you very much for your time today, and we will catch you next time.